So hey guys, I'm yet back again with center of mass, and the topic is with center of mass. Let us today study what actually is the center of mass. So let me give a heading: center of mass. Yeah, here we will talk about the motion of center of mass. Motion of center of mass. So let us take two particles, m1 and m2. There can be more, but on the basics, let us take m1 and m2. So here's m1. Let us make it good. And here's m2. We need more colors for it. So this is the r1 vector of m1, and this is r2 vector of m2. Now let's assume that m displaces from here to here. The mass displaces from here to here. What? And this mass also displaces from here to here. m2. So let me first talk about the initial. What was the initial thing we're doing? So r vector, center of mass of r center of mass. Yeah, it's the the coordinates of center of mass in the xy plane. So m1 r1 vector plus m2 r2 vector by m1 plus m2. You already know that, but it was old one, old, and a new one. Just make it old right here, old, and now the new one comes like this. R center mass equals m1 r1 plus m2 r2 by m1 plus m2. Now this is new. Like the final and initial, it's like that. So there is change in position, right? There is change in position. What is change in position looks like? It's displacement, right? So di is displacement vector. It's just like d, let us call it like that, equals r vector of center of mass of new minus r vector of center of mass of old, equals taking LCM m1 plus m2, m1 r1 plus r, here will be minus as there is difference, so you can quickly write it new, new, and this is old, plus m2 r1 plus r2 minus r1. It will be r2 minus r1 new minus old. Okay, so there is change here. Here is change in position, here is change in position. Let us denote change in position by d. So d center of mass equals m1 d vector 1 plus m2 d vector 2 by m1 plus m2. So here we got a formula. So let us just take it off. It's a formula. So here we got a formula. Then let us we already know this formula, right? The r1, r center of mass equals m1 r1 plus m2 r2 by m1 plus m2. So let us just dy dt, just differentiate it with respect to time, and it becomes center of mass of velocity. That's m1 v1 plus m2 v2 by m1 plus m2. As you guys know, momentum equals mv, p equals mv, that is momentum. So just define it p1 vector plus p2 vector by m1 plus m2 is the total mass of the body and v is center of mass. So you can get a formula. P net is a total. Okay, P net is a total momentum. So P net equals total mass into velocity of center of mass. You can got another formula. Okay, and let's just differentiate it, this one, with respect to time to get acceleration. So acceleration of center of mass equals, you know what acceleration of center of mass is, m1 a1. So as I am telling you, the acceleration of center of mass is m1 a1 vector plus m2 a2 vector by m1 plus m2. So this is the total mass mt, and this is f net external. So let me write it. A center of mass equal to f net external by m total. So f net external equals total mass into acceleration center of mass. That's all for today, guys. Bye bye.